to f of x or f of x equals to x plus 1. These are all the notation. The representation now. One representation can be the rule, as in y equals to f of x equals to x plus 2 say. Another representation could be the function table. Very important representation. Function table. In function table, what you do is that you can draw it horizontally as well as vertically. For my ease, I am drawing it horizontally. In one row, I'm going to pick my input. In another row, I'm going to pick all the outputs. Let's pick some number of outputs and input. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, let's say. Okay. Let's say if x is 0 and my rule is x plus 2, the output will be what? 2. If x is 1, it will be 3. For 2, it will be 4. For 3, it will be 5. Let's pick some negative values. Minus 1, it will be plus 1. Minus 2, it will be 0. Minus 3, it will be what? Minus 1. Plus 4, it will be 6. Minus 4, it will be minus 2. Plus 5, it will be 7. This representation is what you call the function table. Another representation is what you call the ordered pairs. And the ordered pairs are drawn from this function table, or you can use the function rule to get the ordered pairs. How? Let's look at that. The first column is representing the notation, what is in our first row, and in the second row, the second column is representing the very first values when x is 0 and y is 2. When x is 0, y is 2. Okay, this pair is in the order x, y. The order is that first we pick the input, then we represent the output. That's the order, and there are two things here. That's the pair. That's what we call the ordered pairs. So another representation of the function, when you can use the function table, or even you can use the function rule here. The function rule was what? X plus 2. You can even use that. If you don't want to pick any of these values, you can say like for 6 it will be 8. That's one ordered pair. So I'm going to use this function table now. That was just for your understanding. I'm going to use this function table now to represent some ordered pairs. It's 0, 2, comma 1, 3, 2, 4, 3, 5, minus 1, 1. What else? Minus 2, 0, minus 3, minus 1, 4, 6. What else? Minus 4, minus 2, and 5, 7. It also tells me the story that at whatever instance the different outputs were, we got some different outputs for those different inputs. So we can actually draw the rule from the ordered pairs as well. If you look at the inputs, every time for an input, the output is 2 more than the input, correct? Isn't it? So we can actually define the rule from the ordered pairs as well. Now we look at the very last representation of the function for now, because there is another representation, but for that we have to cover another lecture. Okay, the one with which we can wind it up is called the mapping. In mapping, you do what? You have the input at one end, the rule in the center, and you have the output at the other end. And you represent the set like this with an oval circle. Now I'm going to say that if my rule is what? X plus 3, okay? And my input is 0, so the output will be 3. My input is 1, output will be 4. My input is let's say 2, it will be 5. Can you see that every specific input, every specified input has a unique output, right? And that gives us another very important definition of the function, that is when the input is not repeated. When you look at this thing, you will see that every unique input has a unique output. So if you write down the ordered pairs for this one, it will be like 0, 3, 1, 4, 2, 5, right? So as you can see, the input is not repeated. So if I put that in words, it should be like that. The input cannot be repeated. That means two inputs, input 1 and input 2, they can be both mapped to one output. Let's say output 1 only, but one input cannot have two output. Input can never map to two different outputs, output 1 and output 2. Why? Because every ordered pair of the function has a unique input, must have a unique input, or in other words, we can say that every output must have unique input. If we write it down in the ordered pairs, I can say that it would be represented like input 1 comma output 1 and input 2 comma output 1. Now if you look, the output 1 has a unique input here as well as here, right? But if we look into this example, the output 1 has the input I, if I put that in ordered pairs, and for this one the output 2 also has the input I. That means both of these don't have the unique input, or in other words, the input is repeated, so that falls out of the category, or that falls out of the definition of what a function is. So to conclude, we can say that the function is a rule between two variables, the input and the output. The input is what you call the independent and the output is what you call the dependent. One input cannot map to two outputs, but one output can have multiple inputs. Just to make sure that every output has a unique input, and the different representation of the functions that we did so far were function table, ordered pairs, and mapping. There is one very important representation of the function which is called graph. So I'm going to cover that in my other lecture, where I'm going to talk about the basics of the graph and the graph of the function. We're going to talk about that in a separate lecture. Please give me your feedback about how you understood this lecture, and if there were any confusions, post your questions in the comment section, and you can also send us your homework. Don't forget to follow us on Facebook and subscribe to our channel for more updates. Thank you.